Welcome, everyone. I'm Greg Kerala, Director of Analytics at AWS, and joining me today is Harshita Patel, a data warehousing specialist solution architect at AWS. Today, we're going to be covering getting started with Amazon Redshift. On today's agenda, we're going to be talking about challenges of data analytics at scale, and then go into some of the benefits of Amazon Redshift, including introduction, getting started, scalability, and security. Throughout these sections, we'll actually have live demonstrations to help you see Redshift in action and getting started. We'll follow up with some additional resources and then questions and answers to finish out our time together. There's a number of data warehousing trends that make it a great time to get started with Amazon Redshift. These trends include migrations to the cloud, particularly as customers find their existing on-premise data warehouses don't provide the flexibility or scale to meet the exponential growth of data. Also on-premise, there's a lot of costs that are associated with maintaining and renewing hardware. So now is a great time to really look if Amazon Redshift can meet your needs by moving to the cloud. Beyond the new types of data that exist in an organization, we see the rise of event data or the exponential growth of data outside of traditional structured data sources that had fed into old school databases like Teradata and Netezza. These new data sources include IoT or streaming data, event data, log data, that all can be combined with our traditional structured data to provide end-to-end insights across an organization's needs. Amazon Redshift is uniquely positioned to capitalize on all three of these trends and can be a great place to start to monetize or get value from your data. Now, a few challenges in terms of analytics at scale. We've heard about the volume, variety, and velocity for a number of years of data, and if anything, that trend continues to increase. But also, besides just the variety of data and the speed at which it's being captured, customers are really want to enable access to data across the organization, which leads to challenges in terms of performance and concurrency. So can I have my dashboard users, my data scientist users, my data engineers, all accessing the same set of data without having to compromise on performance, regardless of the number of users connected or how frequently they access the data. But also more analytic needs, including multiple ways to access the data. So some analysts might be comfortable using the SQL language. Some might want to access it through programmatic needs such as Python or Spark, through Spark. So kind of the rich variety of ways that we access data. It could be through BI tools or SQL prompts as well. But of course, security and governance is still a key foundation, regardless of the method of access or the type of data. And so can I provide a framework in order to provide compliance, but also just fine-grained access control to the data as well. But then also, we think about a challenge in terms of the increasing cost and inflexibility. And this really comes back to some of the on-premise systems or lifting and shifting these on-premise systems to the cloud, because they come with, typically come with inflexible licensing models, such as perpetual licenses that force you to be locked in at a multi-year contract, but also, not able to handle the rich variety of data, including the unstructured data or machine-generated data that it becomes increasingly important as organizations look to provide analytics at scale. To address many of these needs of modern data at scale, we really want to think about this real-time lakehouse approach that combines traditional data sources in our data warehouse with event data sitting in an object store like Amazon S3, as well as real-time data stored in a transactional database such as Amazon Aurora or Amazon RDS. And so the idea with the lakehouse is to have a single interface through a Redshift query or through a dashboard, but now have a set of tables that virtually map to the data where it resides, whether it's in S3 in Parquet format or even CSV format as this real-time streaming data lands into S3, or the transactional data as it's being loaded in real time into a Postgres database like Amazon RDS or Aurora. And the unique value of Redshift is that we don't have to load all the data into the Redshift database to be able to query and access it. And so we provide a query federation model such that data can be local to Redshift, it can be in S3, or in a Postgres database, but to the analysts, they just see tables and schemas, and they can simply interact with the data. And from a data engineering perspective, we don't have to do the heavy lifting of moving the data. We can simply query the data in place and provide historical data plus the real-time data plus the transactional data into a single view for the business analyst that provides the flexibility and scalability to be able to have insights across all of our organizational data. Now, Amazon Redshift is the most popular cloud data warehouse with tens of thousands of customers leveraging the power of the Lakehouse, as well as the native capability that Redshift delivers for analytics at scale. A few of the customers are listed here across a wide variety of geographies and industries to give you a sample of the richness of the use cases that customers are solving with Amazon Redshift. Amazon Redshift delivers a number of benefits that's leveraged by tens of thousands of customers across the world. The first benefit is to think about integration with a data lake and other AWS services. And so we're using capabilities such as AWS Lake Formation to provide data catalog, being able to use things like CloudWatch for monitoring or data warehouse migration service in terms of ingesting data in. All these capabilities are natively integrated with Redshift to be able to leverage the full power that AWS delivers in terms of analytics. Also, Redshift has the best performance. A lot of the times we look at industry trends in terms of benchmarking data warehouses, including customer feedback directly, and we believe that Redshift delivers the best query performance across the most variety of use cases that customers have. But in doing so, this performance, we also deliver the lowest cost. And so if you think about the pricing model and the stability and predictability that Redshift delivers, I can confidently give access to Redshift across my organization without having the spiraling costs that's typical in other solutions, or the variability that oftentimes leads to surprises. But in delivering this lowest cost and performance, Redshift is also the most scalable. With new features such as concurrency scaling, I can confidently deploy Redshift not just to a fixed workload, but to a number of users that might vary based upon the time of day or even time of month to be able to give access to that data. And while delivering this performance and cost savings, Redshift is also the most secure and compliant with third-party certifications. And so Redshift provides a number of flexibilities such as virtual private cloud, different ways to encrypt data, but also has a rich set of compliance certifications such as PCI, DSS, and FedRAMP to be able to provide access to Redshift across a number of industries and geographies. But in doing so, Redshift is easy to manage. And this has been a point that we'll show in some of the demonstrations, to be able to have access to this powerful capability without having to have dedicated resources looking after Redshift from a day-to-day basis, but provides easy access to be able to manage and be able to give access to data across my organization as well. And to think about Redshift in context, particularly as you're getting started, it's important to know how quickly we've evolved Redshift over the last few years. And so just in the last 18 months, we've released more than 200 enhancements to the Redshift database. We've highlighted a few here. We're not going to go through each one, and we'll have some details in the subsequent sections and demonstrations. But it's important to know that you might have heard about Redshift, a year ago or 2 years ago, but it's worth taking a second look and being able to understand what the capabilities Redshift delivers today, and then looking to the future in terms of the innovation that AWS will continue to deliver in this space in the cloud data warehousing, because giving access to data and getting insights to data is a key component that we hear from our customers. We rapidly want to evolve Amazon Redshift to meet the needs of a modern data architecture.
Thank you, Greg. Now we'll dive into the Amazon Redshift architecture. I'll cover a few of the key features of Redshift and dive into demo to show you how to get started with Amazon Redshift. We'll walk through this architecture from top down. You as a user, you could be using a SQL client or any of your existing BI products such as Tableau, MicroStrategy, or Qlik, or any of your data integration products such as Informatica, Matillion, or Talent. You're connecting to the leader node using the JDBC and ODBC driver. Behind the leader node are 2 or more compute nodes. You can scale a Redshift cluster all the way to 128 compute nodes. When you're executing a query on Redshift, each and every compute node is working in parallel to execute that query. This is what makes Redshift a shared nothing, massively parallel processing architecture. The compute nodes also integrate with Amazon S3 in parallel. You can copy the data from S3 into Redshift, and you can unload the data from Amazon Redshift onto S3. And both of these operations are working in parallel. The green boxes, which are sitting between the compute node and Amazon S3, is the elastic fleet of compute node called as Redshift Spectrum. This provides you the ability to query your data sitting on Amazon S3 in any of the open formats such as CSV, JSON, ORC, Parquet, or Avro. You also have the ability to join this data which is sitting on S3 to the data which is locally in your Redshift cluster. There are only few knobs you need to turn or you can turn in Redshift to optimize your workload. And all of those knobs have been automated. There are worker threads which are collecting, automatically analyzing the tables. Worker threads which are running in the background to reclaim the deleted space, which is automatic vacuum delete, as well as automatically sorting the tables. Based on machine learning, it provides you recommendations to use optimal distribution keys and sort keys. Amazon Redshift Advisor is DBA's best friend. It is monitoring your operational statistics on a daily basis with the lens of best practices. And it provides you recommendations which are tailored to you, which are impactful and actionable. This dramatically reduces the effort required to manage and maintain a Redshift workload. Now we'll dive into the demo to create a data warehouse with Amazon Redshift. To create a data warehouse with Amazon Redshift, I have logged on to the AWS console in my account, and I'm at the landing page for Amazon Redshift. So let's get started. We'll click on Create Cluster, and there are a few things that we need to populate. The first is we'll provide a cluster identifier, which is going to be your cluster name. I'm going to name it Webinar, Redshift Webinar. I'm going to select the new RA3 instance node, which is with the managed storage. I'm going to select RA34XL, going to use 2 compute nodes. And with the 2 compute nodes, you can have 128 terabyte compressed storage. I'm going to pick the default. This is the database name, which is dev is default. You can choose a different database name, and you can also specify a different port number. I'm going to use the default here. For the user, the master user, you can name a different master user. I'm going to use AWS user and provide it a password. We're going to leverage this password for the rest of the subsequent demos to log into the Redshift cluster. Now we'll select the cluster permission, and this cluster permission where we are going to use an IAM role. This IAM role will be attached to the Redshift cluster so that it will provide access to read and write to S3, Amazon S3. We are going to use the default settings, and now we are going to click on Create Cluster. The cluster will be created in a matter of minutes. As we can see, the cluster is getting created. While our cluster is creating, let's take a look at data modeling and data types in Redshift that are supported. Based on your use case and your requirements, you can choose different data models and implement them on Amazon Redshift. You could choose a star data model where you have facts and dimension, or a snowflake data model. Some customers, based on their workload, they also denormalize the tables. With Amazon Redshift, you can also implement data vault data model. Within Redshift, when you get started, you create a table. When you define a table, you define columns. And based on the data profile, you can provide different data types for those columns. They could be numeric, text, date, time, as well as geometric data type for your geospatial data. Here is a sample map of Airbnb location, 23,000 Airbnb location within Berlin on the selected polygon. There are over 40 plus functions that you can use to do geospatial analysis in Amazon Redshift. Now that we have defined the table and column, let's look at how you can ingest the data or load the data into the table and how you can start analyzing the data leveraging Amazon Redshift. The most performant way to ingest the data or load the data into a Redshift table is leveraging the copy command. Within the copy command, you specify the table that you want the data to be ingested in and a path and a location of where your data resides on S3. You provide IAM role so that Redshift cluster has access to ingest the data or read the data from S3. Copy command supports different file formats: CSV, text, JSON, ORC, Parquet, or Evro data. Materialized views have been GA. Let's take a look at one of the examples of how you can leverage materialized view to make your workload performant. Say, for instance, you have a very complex query and you have created a view which is joining n number of tables, you have filters, you have aggregations. When the end users are running the query against their view, for every single execution, it has to join the data from the underlying tables, apply the filters, do the aggregation for each and every query execution. If this complex view is replaced by a materialized view, the computation of the query is persisted. So when the queries are now executing against the materialized view, they are significantly faster. The second use case is the materialized view. When the underlying tables, which are used in materialized view, when they are changing or getting refreshed, you can incrementally refresh your materialized views. This significantly helps the performance of your ETL pipeline. Amazon Redshift supports stored procedures in PL, PG, SQL format. You can write DDL operations, DML operations, as well as select queries within stored procedures. If you are migrating to Amazon Redshift from your traditional data warehouses where you're leveraging stored procedures for your ETL pipeline, you can use AWS Schema Conversion tool to convert those stored procedures into Redshift equivalent format, which is PL, PG, SQL. To build your data pipeline, you can continue to leverage your existing products. If they are able to support ODBC or JDBC driver, they integrate well with Amazon Redshift. But if you are embarking your journey and if you want to leverage the native AWS services to build your data pipeline, Amazon Redshift integrates with AWS database migration services, which you can use to load the data into Redshift from your source systems. To perform extract, transform, and load, you can leverage AWS Glue or Amazon EMR, which is the Hadoop managed service. For machine learning, you can leverage Amazon SageMaker, and for visualization and dashboarding, you can leverage Amazon QuickSight. All of these services integrate natively with Amazon Redshift. Now let's dive into a demo. Let's see how we can get started with Amazon Redshift, the cluster that we had instantiated in the previous demo. We are going to connect to Amazon Redshift cluster, leveraging Redshift Query Editor. We'll get started by creating a table, define columns, corresponding data type. We'll leverage the copy command to load the data into that table from S3. And as soon as the data is loaded, we'll start analyzing that table. As we can see, the cluster is now created and in order to start querying the cluster or start defining a table and loading the data, I'm going to leverage the Redshift query editor to connect to this cluster. So over here, we'll select the cluster and we'll click on Query Cluster. Here is where we are going to define the connection. And this is the cluster that was launched, which is Redshift Webinar. The database, I have chosen the default, which is dev. And the user is AWS user. And I'm going to type in the password. And we'll click on Connect to Database. Now we have connected to the Redshift cluster. The first step is within the database dev, we are going to get started by creating a schema webinar. Within the schema, you can create tables, stored procedures, views, materialized views, and user-defined functions. So the first step is we are going to create a schema, and within that schema, we are going to create the sales table. Here are the different columns with the corresponding data type. Once that table is created, we are going to run the copy command to load the data into the table. So let's get started by creating the schema first. As soon as the schema is created, we are going to create the sales table. Now that the schema is completed, we are creating the table. So Redshift is columnar in nature, and you can write NC SQL to analyze your data. The table is also created, and this is the copy command. In the copy command, I've specified the table name and the path to the S3 location where the data resides. So let's go ahead and run the copy command. Now we're going to click on the schema webinar. The data load into the table has completed. Let's preview data from that table. So we can do select star from webinar. So we'll select the schema, and then we are going to select the table. And to sample the data, let's take a look at 10 records in that table. So now we know the columns and the corresponding data values in the different columns. Now we know that the data has been loaded into that table. Let's run an NC SQL and analytical query to identify the top 100 seller IDs. So over here, we have the top 100 seller IDs. You can export the data in a CSV format, text, or HTML. And if you want to do a simple visualization, you can also visualize your data leveraging the Redshift query editor. So with this, we connected to the Redshift cluster, leveraging Amazon Redshift Query Editor. We created a schema, a table within that schema, sales. We loaded the data leveraging copy command, and we started analyzing that data using ANSI SQL. Amazon Redshift Spectrum allows you to extend your data warehouse, which is Amazon Redshift, to your data lake. It allows you to query the data as it is on S3 in any of the open formats without having you to ingest that data into the Redshift cluster. It also provides you the ability to join the data which is sitting on the data lake to the data which is locally on Redshift cluster. We have seen a number of different use cases that customers leverage Amazon Redshift Spectrum for. The first use case is where they have their clickstream data, which is near real-time data arriving on S3. Without ingesting the data into the Redshift cluster, they leverage Amazon Redshift Spectrum to query the data directly, which is arriving in near real-time on S3. The second use case is to leverage Amazon Redshift Spectrum for ELT. Before bringing and ingesting the data directly as is into Redshift, they push down the computation, they push down the transformation and the filtering at the spectrum layer before that data is ingested into the Redshift local tables. We have also seen customers leverage Amazon Redshift Spectrum to flatten out the nested JSON dataset. A number of BI products, they support Redshift Spectrum, which are external tables. So from an end user perspective, when you render the query, it's hitting Amazon Redshift, and Redshift is pushing down the computation if the data is coming from the S3 layer. Federated query was recently launched. It is GA. This takes a step further. We saw how Redshift Spectrum allows you to extend your data warehouse to the data lake, which is on S3. With Federated query, you have the ability to run analytical queries directly on your operational data stores, such as if they are on Aurora Postgres or RDS Postgres. You have the ability to join this data, which is your transactional data, OLTP data, to the data in your warehouse and the data in the data lake. From an end user perspective, you create a unified view, and when they write a SQL, they write ANSI SQL, and the Redshift engine pushes down the computation to the respective data sources, minimizing the data movement to render the query results. To unload the data from Redshift, you leverage the unload command. Unload, when you execute, it is unloading the data from the Redshift, Amazon Redshift cluster in parallel on S3. You can unload the data in a CSV format or Parquet format. When you unload the data in a Parquet format, you can also specify the partition key that the data will be unloaded by. We'll dive into the demo where I'll walk you through the lakehouse architecture. We'll look at this picture on the right-hand side, on my right-hand side. The use case is I, as a data analyst, I want to query the data as it is on S3, which is the product review data in the Parquet format. I also want the ability to join that data, which is on S3, with my customer data and customer demographics data to further analyze the data and gain more insights. Once I have completed the analysis, I want to push down that data or unload the data back into the data lake in the Parquet format so my other analytical applications can consume that data. So I, as a business analyst, I want to analyze the data which is sitting on S3. So before we can start analyzing the data, let's take a look at how does the product review data look on the S3 side. So for this, I'm going to go to AWS Glue. One of the features of AWS Glue acts as a Hive metastore or a catalog. So within that, I have pre-created a database input data. And this is the product review Parquet, where Glue stores the metadata about the data. So let's take a look at how the data is. So this data is in the Parquet format. This is the location of where the data resides on S3. This is 160 million records, and these are the different columns and the corresponding data type, and product category is what this data is partitioned on S3. To start querying this data, the first step is to provide Amazon Redshift access to the Glue catalog. This is where we are going to go ahead and create an external schema. The data catalog over here is input data, which is the Glue catalog or the Glue database. And we have provided an IAM role, which provides Redshift, Amazon Redshift access to the Glue console and the data on S3. So let's get started and run and create this external schema. As soon as the external schema is created, we will check whether we have the ability to query this data. Let's expand this and let's take a look at, yes, S3 input is the external schema. As soon as we have created, all the tables are listed and visible onto the Amazon Redshift site. And once these tables are visible, let's first of all see if we can identify how many record counts are there, or even see if we have the ability to query this data, product review data from the Redshift cluster. So the query has completed and it has returned 160 million records that we saw in the glue table. Let's sample this data to see the corresponding columns and the values and the data type in those columns. So this query is executing directly from S3 and it's rendering the results back on the client side. So the query execution has completed. Let's take a look at the data and let's see if we can wrap the lines so we are able to see all the columns and the corresponding values. Perfect. Now I want to analyze what are my different product categories and what is the rating for those products. So I'm going to use this query over and over again in the subsequent analysis. So let's go ahead and create a view where we are wrapping this analytical query within a view, and in the subsequent analysis, we are going to leverage this product review aggregate. Okay, it's creating the view. As soon as the view is created, let's identify the top product category in home and grocery, which is highly reviewed. As soon as this query runs, I'll get insight into the products that are highly reviewed. So let's take a look at San Francisco Way 1 Cup is the most reviewed product. Now let's take this step further. I now want to join this product data with my customer data, which is in Redshift Local, and I want to identify across the customers all the product categories and do 30 and 90-day rolling averages to look for trends. So now this query that we are going to run, it's going to join the data, which is on S3, which is the product review data, to the data which is locally on Redshift. Let's run this query through. And as soon as this analysis is completed, I have insight into the state, what is the rating of a product, what is the name of the product, and I have completed my analysis. And once the analysis is completed, we are going to push down this data using the unload command onto S3. Okay, so here is the list of the products and customer state, Georgia. This video games was being reviewed the most. And as soon as this analysis has been completed, we are going to push down this data onto S3 in a Parquet format, and we are going to partition this by product category. So let's go ahead and run this unload query. So while unload is executing, it's pushing down the data to S3. So let's take a look at this Redshift bucket. This is the bucket. And within the bucket, we have this RLL data lake report part. And this is where the data got unloaded. The partition key is product apparel, and these are the Parquet files which got unloaded from Redshift. So we launched the cluster, created our table, we ran analytical queries both on our data lake as well as Redshift. Now let's look at monitoring. Redshift console provides you a unified look into a view into the health of your clusters in your account within a region. And if you want to drill down further as a DBA into your workload, how your workload is performing, it also provides you a dashboard to look at individual queries, running queries, completed queries, and it also helps you pinpoint and identify the queries which are taking longer, where you can further drill down into the execution steps of that query. Now let's monitor the workload in the Redshift cluster. Let's make the first stop at Redshift Advisor. Redshift Advisor runs daily, looking at your operational statistics and provides you recommendations which are tailored to you, specific to your cluster. The recommendation it has made is to optimize the distribution keys, optimize the sort key. Let's take a peek into what those optimization recommendation looks like. So over here is to change the distribution key on the specific table, and it provides you an altered statement that you can copy and paste to change the dist key on the table. Now let's look at the health of the clusters. The Redshift console, you can take a look at the health of your cluster. You can have n number of your clusters in the same account, in the same region. And if you want to drill down into the specifics of a specific cluster, you can look at the CPU utilization, the disk utilization, and you can also take a look at the health status of the cluster. And if you want to drill down into the specifics of your workload and individual queries, you go to the query monitoring dashboard. You can pick and choose if you want to review the top 100 queries, or if you want to look at the queries which are taking longer than 10 minutes to run. Over here is the view of the dashboard, and it will display the queries that have completed the corresponding execution time. If you want to drill into specific queries, you can click on the query ID, you can look at the query, as well as you can look at the execution plan of the query. Now I'm going to hand over to Greg, who is going to walk us through scalability and security with Amazon Redshift.
Thanks, Arshita. Those are great demonstrations to see the power of Amazon Redshift across a wide variety of use cases. The next topic we want to cover is how Amazon Redshift can serve all of your Elastic needs in terms of compute, data, users, and workloads. To think about elasticity, and we're going to start with compute elasticity, it's important to understand the different ways we can scale Redshift, both horizontally and vertically. For horizontal scaling, it's simply about how can I speed up my running jobs for a fixed period of time, such as end of month, or if I see increased usage, to be able to meet that usage, that planned usage ahead of time. In the case of horizontal scaling, we have a feature called Elastic Resize. Elastic Resize allows me to seamlessly go between 2-node cluster, 4-node cluster, back to 2-node cluster, or 4-node cluster, an 8-node cluster, back to 4 nodes. And this really meets the horizontal scaling capability to be able to address, the timeliness of configurations and jobs that are running on my Redshift cluster. The second kind of scaling is to think about vertical scaling. And this is where I have unplanned usage, or I have, spikes in terms of, people logging into the dashboard in the middle of the day, being able to get access to more data. And it's not a question of changing the size of the cluster, but it's really thinking about how I can automatically scale Redshift to meet those spikes in demands. And for that automatic vertical scaling, we have a capability called concurrency scaling that requires no administration to be able to seamlessly grow and shrink my Redshift cluster. And so thinking about these two different horizontal and vertical scaling and how Redshift can address both of them. The first thing I want to dive into is compute elasticity with concurrency scaling. And the benefit of concurrency scaling is I can simply provide a set of rules such that at the workload level, such that I dynamically and automatically scale out my Redshift all through the same endpoint. So there's no interaction or no action the end user needs to take. There's really no action that an administrator needs to take. It's simply setting a policy that allows me to automatically scale my Redshift cluster regardless of the number of concurrent queries that are being used, but then provide the governance such that I can limit it to a certain set of users or group of users. And so Redshift with concurrency scaling can simply look at the number of users that are connected, look at the compute resources being leveraged, and within a matter of seconds, I can simply dynamically grow that amount of compute based upon the workload. And as soon as that workload goes away, we dynamically shrink back to the base size of the cluster. And what this allows is virtually unlimited concurrent users and queries while maintaining your service level agreements. And if you understand the history of Redshift, this is really a big change in terms of being able to serve all the needs of the organization, regardless of the number of users. And this additional compute that is added into the Redshift cluster is billed by the second. So if I just have peaks of a few minutes, I simply can pay the additional per second charge just for those few minutes. But also in terms of pricing, Redshift delivers 1 free hour of concurrency scaling each day. And if you think about AWS billing being monthly, what this effectively delivers is 30 free hours of concurrency scaling per month. And so as I think about these peaks and spikes in demand for my queries, as long as I kind of stay under that 30 hours a month, then I'm able to leverage the dynamic capability of concurrency scaling for free. In fact, 97% of our customers to date have found no additional charge by enabling concurrency scaling for their clusters. Of course, the more you use Redshift, the more you're leveraging concurrency scaling, you'll want to take a look at the CloudWatch metrics just to make sure you're staying underneath that free tier. But knowing that you have this powerful capability to automatically scale to the demand of my clusters can really benefit in terms of consistently fast queries, regardless of the number of users that are connected. Well, let's say if you find a situation where you are constantly using concurrency scaling, and there's some concerns about perhaps exceeding that 30 free hours per month or 1 free hour per day, this is really where we want to think about the next kind of scaling compute in terms of elastic resize. And so what elastic resize lets me to do is simply reset the base number of compute nodes that are in my cluster. And this is in place, so I can simply say I want to go from a 4-node cluster to 8-node cluster, or I can even shrink back to a 4-node cluster if I already am at that 8-node cluster level. It simply allows you to very simply move that base cluster performance. Of course, concurrency scaling is still available, but this, from a price perspective, oftentimes can be more effective if I have a significant increase in demand of my cluster itself. And so with elastic resize, again, I have the same end node or connection point to the leader node of Redshift. And as I change dynamically the number of nodes in the cluster, the operation, succeeds within a few minutes, right? And there's almost little to no disruption to end users while this elastic resize is taking place. And so these two capabilities, leveraging elastic resize to set the base cluster, and then concurrency scaling to be able to handle unforeseen peaks in demand, really provide a game-changing view of Amazon Redshift to deliver access across all the organization's needs, regardless of the number of users. The other piece that is new and significant in terms of scaling with Redshift is our new RA3 nodes with Redshift Managed storage. And so with the RA3 generation of Redshift nodes, you're able to scale and pay for compute and storage independently. And so from a sizing perspective, from the way we think about Redshift, now we can think about what are the amount of compute for most of my queries that I can size my Redshift cluster by. And because storage is now in the Redshift Managed storage, you're simply able to load as much data as needed, taking advantage of the compression of the columnar format of Redshift, but simply think and disaggregate the storage from the compute. And so I can load much more data and not have to worry about sequentially adding compute just because I loaded more data. Or if I have computational processes that require more compute, I can simply add more nodes or take advantage of concurrency scaling to be able to fulfill those requests. And so it is a difference in terms of this combination of Redshift Managed Storage with the RA3 instance types that really deliver world-class performance in being able to take advantage of tiering of data between different storage mediums within Redshift to be able to deliver fast, consistent performance, all without having administrators to have to think about this. So you simply provision the amount of compute and you load your data leveraging Redshift Managed Storage, and Redshift handles the rest of the movement of data plus the ability to store all your data. Now, thinking about security, as you mentioned a little bit earlier, Redshift is security is our top priority. And thinking about there's no additional charge from Redshift for leveraging this security framework. And so when you think about the total cost of ownership of Redshift, knowing that all these capabilities in terms of end-to-end data encryption, integration with IAM and SAML federation, of course, network isolation through a virtual private cloud, thinking about the database security model for user groups and privileges, including column level access control, the auditing, logging, notifications, being able to track which users are loading data, querying data, accessing data, and all the certifications in terms of SOC 1, 2, 3, FedRAMP, HIPAA eligibility. are all provided as a core part of Redshift for no additional charge. And so whether I'm an organization in an industry that requires strict compliance, or a customer that's simply managing their customer information that needs to have a high level of assurance in terms of security, Redshift can deliver that in a compliant manner without having to think about additional complex pricing metrics to be able to accomplish that. Now, we've covered a lot today. We wanted to provide an overview of getting started with Redshift, but there's much more information that's available. And so we always recommend AWS at amazon.com/Redshift for the most information in terms of up-to-date feature releases, new customer highlights that are being customer story highlights that are being published on that page, and just really your bookmark for your overall reference. But some more advanced training and features is a number of links provided here that help you get started in terms of being able to load data, leveraging materialized views, some of the labs that we have in terms of being able to have tools and utilities. And also, I think an important one is if you're looking at Redshift and you want to put it through its paces with the sample data set, such as TPC-DS, we actually have a GitHub location where you can download some of the benchmarks to be able to quickly and easily test Redshift. And then, of course, we always recommend you look at leveraging your own data to be able to see your queries and performance for Redshift as well. So having said that and gone through a lot of material today, we're happy to take your questions, and we look forward to speaking with each of you in the future.